And we have a very special guest, so Chris Raymond, who is the Chief Sustainability Officer for the Boeing Company and Senior Vice President of Global and Enterprise Sustainability and a member of the company's Executive Council. As Boeing's Chief Sustainability Officer, Chris Raymond is responsible for further advancing the company's approach to environmental, social, and governance priorities, stakeholder-oriented engagement, reporting, and company performance. Raymond has actually a very storied career at the Boeing Company, serving in a wide variety of engineering, leadership, and executive positions, including multiple vice president appointments across the Boeing enterprise. Chris Raymond is an associate fellow of AIAA and a fellow of the Royal Aeronautical Society. He's part of the Clean Skies for Tomorrow Coalition, is a World 50 member, and serves as an advisory board member with the Heritage Group, Dell Technologies, the MIT Climate and Sustainability Consortium, and the University of Illinois Alumni Aerospace Engineering Alumni Association, or Alumni Board, excuse me. He's also an advocate for the International Aviation Women's Association. Chris earned a Bachelor's of Science degree at the University of Illinois. I heard they do pretty well in that, actually, as it turns out.
I got through it. I couldn't today, but I got through it.
That's right. As well as an MBA and a contract management certificate from UC Irvine. So let's give a warm Illini welcome to Chris Raymond. Thanks so much for being here.
Hey, good afternoon, everybody. I have had a lot of jobs at Boeing, so if you want to talk about anything to do with careers or anything to do with Boeing or aerospace engineering or engineering as it relates to growing up in a company, I'll take questions on anything you want. It doesn't have to be on sustainability. I tell you a little story about how this even became a thing at our company. Was about two and a half years ago, I was running strategy and corporate development for the company, so M&A and the like. And we had started to identify sustainability as things we should be putting more and more attention on going forward. And then we had two terrible MAX accidents. And then there was a pandemic. And we started talking about the fact that, as part of earning trust with people, whatever stakeholder group you want to talk about of the company, perhaps we needed to not wait any longer to put more focus on sustainability. And so as things would happen in companies, you get a call. I got a call from our CEO, and he said, remember that conversation we had about putting more attention on sustainability? How about we do that right now, and will you do the job? Will you be Boeing's first chief sustainability officer? Of course, when the CEO calls, you say yes, and then I went home and I Googled, what does a chief sustainability officer do? True story. And I think, I was trusted to learn the topic of sustainability, but I had 35 years at the time, 37 now. I had 35 years in the company. And what I really found was, this is a subject that's entering every company and a lot of industries, and you have to figure out how to make it appropriate for your industry and your company so that your companies can understand the subject and then figure out what has to be done in the context of your industry. So what I really find my job is a lot of the time now is sort of just leading change. It's absorbing what's going on in the world, translating it and bringing it back into Boeing to sort of say, this is why we have to care more about this. And what's that mean if you're in human resources? What's it mean if you're in finance? What's it mean if you're in pick your favorite function of the company. Accounting. There's going to be carbon accountants in the world, just like we have financial accountants in the world. And then what's it mean to engineering? The subject near and dear, to my heart. And how do we intersect this topic with things like systems engineering or MBA programs and the like? So it's a big, broad word. We had to teach ourselves and catch up to the rest of the world as a company. And we had to learn that sustainability, depending on where you are in the world, equals ESG. It does equal all the environmental stewardship activities you're practicing as a company or not. It does equal what your social practices are in the company. How transparent is the company? What kind of culture do you have in the company? Is it inclusive? It means those social things in the company. How do you engage your communities? But it also means how you govern your company, and that's the G. And that one's a little harder, but it's things like, does your board of your company care about this topic? Is anybody on your board knowledgeable about this topic? Is your CEO knowledgeable about this topic? How do they take their meetings on this topic? Do they ever pay attention to this topic? Those are questions that are increasingly asked by some of our stakeholders. Some of them are investors in the company. So the subject, depending on where you sit, might mean a little different things to different people, but it's a big, broad subject. I think recognizing I'm speaking largely to an engineering audience today, I would just say when we look outside and you look at some of the headlines that are happening in engineering and aerospace, you know, one big thing for our industry is that the carbon emissions that are created in the operations of our companies and in the use of our products and then by our industry are a risk to be managed and an opportunity going forward. And the stakeholders of our industry care about this topic. And I'll define what I mean by stakeholders in a couple minutes, the groups of people that have interest in our company or in our industry. And I always try to remind everybody, usually when I'm in big rooms like this somewhere in the world, I'll ask people to raise their hand. Did you fly here today? Yes or no? Did you carbon offset your flight? Yes or no? And you will get very different responses, but I've spent my whole life in aerospace. I've been all over the world for and with aerospace, and I can tell you there's huge societal benefits. All of you understand it. It connects the world. It protects the world. It creates cultural bridges between the world. I believe there's a ton of societal benefits associated with this industry, but it's a target. And as it grows, it has to grow more sustainably. So you see some headlines up there, International Civil Aviation Organization. That's an organization that's made up of about 194 countries and the aviation leadership of those countries. It's where the world gathers to talk about aviation policy and agree on things. IATA is the International Air Transport Association, the world's airlines. It's where they go to meet on things and agree on things and set goals on things. And our industry has achieved alignment between the governments that deal with aerospace and the airlines themselves on this net zero by 2050 goal. I'm not really sure I can point to too many other big industries that actually even have the means to come together and agree on a goal like that. So in that sense, I think our industry is pretty special, even though the challenges are immensely hard. But it doesn't just stop with civil aerospace. On the right side of the chart, you'll see some Air Force generals. You'll see that this is entering into the governments and the ministries of defense, and they're having to figure out, well, what's this going to mean to them? Here in the United States, our president proposed that any federal contractor that does over $50 million of business with the government needs to disclose certain environmental information about your company and your carbon emissions and what you're doing to lower them. And it's going to enter companies, whether it's by regulation, it's just the right thing to do, or if you want to attract people or improve trust with people, you better be doing it. So whatever your motivation is, you see companies putting more and more attention on it. I'm an example of that. I would just say, you know, probably the industry gets a reputation for being a bigger carbon emitter than it maybe actually is right now. This is what aviation's contribution to the global carbon emissions are today, about 2.5%. A lot of audiences I'm in are kind of surprised by that. And I don't show that number to say we're only 2.5% of the problem. I show that number because despite whatever your percentage is, there's an expectation you're doing something to reduce it, and we're a growing industry. But if I put that in a little context for you, you see electricity and heat. Air conditioning contributes 4 to 5 times carbon emissions of what aviation does. Cement mixing is about 3 times. So there's a lot of industries that are going to have a hard time reducing carbon emissions. It's going to take a lot of solutions that we don't yet have today, and aviation is one of those industries. But if I looked at that in the context of just transportation, now it starts to get a little more real for us here in the aerospace engineering world. Now we're 12% of the problem. We're growing, and if we look around that circle, you might argue that those industries will have a relatively easier time getting off of fossil fuels, whether it's electric cars, electric trucks, ships powered by ammonia. There's going to be other solutions that emerge for all of us, and we're going to grow, and our percentage on a chart like this will likely increase. And maybe we'll go from not just being a perceived problem to a major problem, And you've got people thinking about that and starting to try to regulate that or have expectations on what the industry is doing to decrease those carbon emissions. And by the way, I'll say carbon emissions. What I really mean is CO2 equivalents. There's other things besides carbon that you all know are becoming big issues, especially in aerospace, nitrous oxide, methane. Some of these other things are also big problems, but we kind of lump all that under CO2 equivalent when we talk about it as an industry. But this is kind of where we sit in the world's problem set. So like a lot of companies, 2 years ago, Boeing started producing a sustainability report. Like a lot of companies do. Europe companies were required to do this prior to US companies. And US companies still aren't really required to do it, although I think you'll find if you looked at any of the large corporations in the United States, they're doing it. It usually occurs a couple of months separated from their annual financial reports. We decided to call our sustainability report Sustainable Aerospace Together because there's no way this happens without cross-sector industries also helping. That's why I think Phil's class on sustainable aerospace and aviation is so powerful, because he's trying to intersect aerospace education with economics, with agriculture, with energy, with policy, and create an awareness of how those things play in the technology. That's super powerful. And like a lot of companies, you will hear in their sustainability reports, you'll hear this term materiality. And what that really means is everybody's trying to make a judgment call on what's most important to the stakeholders of their company. And in ours, we pick these 6 things. I won't go into each of them, but everybody will try to pick out certain things they think are most important to the stakeholders of their company or to their industry. And in our industry, it starts with safety. I often say you can't have sustainable aerospace unless you have safe aerospace. Starts with the people that come to work every day with a Boeing badge on, starts with all the people that fly and trust your products, and then it goes on from there. But those are the most important things. And so we highlight these 6 areas, and we can talk about any or all of those, but that's what we choose to kind of highlight in the report. And these reports have become long in most companies. I would argue probably between 70 and 100 pages long that most companies are now publishing. And they're long because you're trying to address several things. You're trying to address the myriad of companies that are now rating you on your sustainability, and they all have a criteria or a framework or a set of things that they want to see in your report, and they check their box that you covered it. There's some of those people. Then there's just different groups of people. And when I talk about those groups of people, we put them in these 6 categories, starting with our own employees. If our own employees can't talk about what the company's doing, who else is going to? And so our own companies need to be our ambassadors, if you will, for what the company's trying to do to become more sustainable. So we've got to speak to that audience, but we've got to speak to our airline customers, our ministries of defense, our regulators, our investors, our communities, and our supply chains. So we think of these as groups of people. We have to earn their trust. And part of earning their trust is to engage them on sustainability. And so we can talk about any or all of that, but there's a lot of regulation emerging in the world focused on aerospace and aviation sustainability. In some cases, it's incentives to try to help the growth of renewable energy. And in some cases, it's actually penalties. And some of those penalties would say, let's curb the demand for aviation. Let's fly less. There's a proposed rule over at Schiphol right now in Amsterdam that would cap the number of flights that go through Schiphol Airport in a given year. And if that passed in the EU right now, it would be 60,000 less flights than were flown in 2019. So those are the kind of things that are emerging in the world to try to curb the carbon emissions created by aviation. I mentioned the societal benefits. I would just say this: the industry moves a lot of people. It was about 4.5 billion in 2019. It's about 7 trillion of goods when you think about cargo and all those things. That only went up in the pandemic. Everything you order at your house and it shows up tomorrow, chances are there's an airplane in that supply chain somewhere. So people don't think about how aviation and aerospace are in their lives, and we almost take it for granted now. You can get on a plane and go anywhere you want in the world. So there's immense benefits, and there's a lot of jobs. These aren't Boeing numbers. These are an aviation organization called Air Transport Action Group out of Geneva, Switzerland. And they did a whole thing called Benefits Without Borders to try to bring to light the benefits of the aerospace industry in the world. And I would argue the pandemic reminded us how important some of those benefits are, like connecting with one another in person and seeing places in the world, as an example. And the war in Russia and the Ukraine, that reminded us how important national security is. And I've had some people say, well, if you care about sustainability, aren't you anti-defense or anti-military? I would argue it's the opposite. I think one of your social responsibilities of a country is to have humanitarian relief for peacekeeping operations. And I think we were reminded about that as a world this past year, unfortunately. So a lot of times the question will then turn to, okay, fine, Boeing, what do you all think it takes to decarbonize aerospace or make aviation more sustainable? And we talk about it in these 4 topics. First, fleet renewal. We talked today, but our industry has done an amazing job because of great engineers at improving the fuel efficiency of flying. I'll put it this way, if you got in your car by yourself in New York City and you drove to San Francisco, you would take however many days that would take, even if you went straight through it, to a couple of days, probably 3 days, 3 to 5 days, let's say, you'd probably burn like 140, 150 gallons of gas. If you just did that by yourself, drove yourself there. If you got on a 787 or on a modern airplane and did that same thing, you all know you're there in 5 hours, 5 or 6 hours. You probably consumed on your per person about 30 gallons of gas, 30 to 35 gallons of gas. So on a per person basis, this industry has radically improved fuel efficiency. And the airlines know this. In fact, they expect every new airplane will come out and be somewhere in the neighborhood of 15 to 25% more fuel efficient than the previous versions of airplanes. And before the COVID, we were in a big replacement cycle that was starting to go on. Boeing had new products coming into the market, Airbus had new products coming into the market, and we were starting to see those older airplanes replaced by newer airplanes. That will always be a huge component of lowering the carbon emissions of the industry. And it's a huge challenge on the next product because people are starting to say, well, are you engineers, are you capable of producing more airplanes with those kind of fuel efficiency improvements? Are we starting to run out of material improvements, aerodynamic efficiency improvements, fuel improvements? How are those engine companies coming along? Are they capable of another airplane with another step forward of 15 to 20, 25%? It's a big question in our industry. Second, there's little things that we talk about in our industry and the operational efficiency gain. I just came yesterday, spent the day at a major US airline in their corporate headquarters with a bunch of their team. All we did was talk about what they're trying to do on this chart. And they're really focused in that second operational efficiency column. Like, we can't buy new airplanes every day. So we've got to figure out things we can do to make our operations more efficient. And you wouldn't believe how hard they will work to find 1 percentage point improvement in fuel use. Incredibly hard. Or to save a couple pounds on a flight with water. Or to not have their engines burn as much fuel when they're taxiing around on the airfield. They think about this stuff. They are super focused on this stuff. But the big question in our industry, I would argue, is how is renewable energy and advanced technology going to intersect aviation and what's possible? And we have to work a lot on this. I'll talk a little bit about this, but in the renewable energy column, just to oversimplify it, we think about 3 things: sustainable aviation fuel, electricity, and hydrogen. You all know there's not enough sustainable aviation fuel in the world right now, but there's a lot of people focused on how we get more. Electricity is not produced greenly anywhere in the world, and there's not hydrogen made greenly really anywhere in the world. So if we're going to think about those as energy sources for aviation, we've got to think about the life cycle emissions of any one of them that we're going to think about and incorporate that into the analysis that says, how much did I improve the carbon emissions of the industry by those different energy sources? That's part of the metric we have to keep in front of us. Boeing spends a lot of time in sustainable aviation fuel. I'll talk about that in a minute. The yellow airplane you see in the middle there, that's an airplane called Cora. We announced the 6th-gen version of that would be submitted to the FAA to try to certify not just an eVTOL airplane, but an autonomous one. And we're going to learn a lot on what it takes to certify autonomy to 10 to the minus 9th safety. And we don't know how to do that right now, nor does the FAA ever had to try to solve that problem. But we've got to work with our regulator to figure out how will we certify those things. In the lower picture there, the oversized load, I included that picture for you just so you get a sense of the scale. That is a composite, linerless fuel tank for liquid hydrogen, made out of the composite material system that we use to make the 787. As big as that is, that holds the amount of liquid hydrogen we would need to fly a regional airplane about 800 nautical miles. Just to give you a sense of the scale when we start thinking about these different forms of energy carriers and what it's going to mean to long duration aviation. And then advanced technology. In the upper right, very honored to report that yesterday NASA awarded something that they call the Sustainable Flight Demonstrator Program. I think it's a critical program for the country. I think it's a critical program for U.S. aerospace. And I think it's an honor that they selected Boeing to be their partner on that. And that's just a rendition of about 12, 15 years of work looking at both aerodynamic changes, the manufacturing changes that'll have to be embedded to make something like that a reality, different engines that we might use on the airplane. So it will be sort of a national demonstrator around sustainable aviation technologies. And it'll go on over the next few years. That's the concept we had submitted around a transonic truss-braced wing. Many of you have been involved in that, I think, and touched that program over the years through things like Cheetah. But that is just announced yesterday, actually. And then, you see that it's going to not just be in the airplane itself, but it's going to be in how we build it. It's going to be in things like additive. It's going to be in these sort of things. And the way we'll think about this at the company is we have products that are in the market and flying today. We have demonstrators that are things we're actually building and learning from. And then we have paper analysis, if you want to call it that, or advanced aircraft configurations. And that we call future flight concepts. Because we've got to start configuring airplanes and learning, applying engineering and physics to what's possible with things like hydrogen fuel cells. What's possible with an all-battery electric airplane? What will be required to configure an airplane if we're going to fly it on liquid hydrogen, given the volumetric constraints, the temperature constraints, the pressure constraints, cryogenic systems. So we're going to learn a lot from all that, but we got to be working on it all. And you will hear us say at Boeing, sustainable aviation fuel and, because there'll be some people that will say, well, isn't this an or question? Yeah, I know about sustainable aviation fuel, but can't you just fix this problem with electricity or with hydrogen over time? And our view is we have to work on both. But if we're serious about net zero by 2050, this industry needs a bunch of sustainable aviation fuel and whatever else can be contributed through electricity and hydrogen. So it's an and question, not an or question in our view. And then down here, I won't go into it too much, but I mentioned that ICAO sits over our whole industry. And through IATA and ICAO, there's been an agreement between airlines and government that if we approach 2050, and we haven't totally resolved the carbon emission problem in the industry, then we have an agreed to framework for how we'll approach offsets. Quality, the kind of framework for those. And I know offsets are a controversial topic. You might be sitting there going, I hate them or I love them. But I would argue they're sort of a necessary component of the transition and how you get to net zero. And the aerospace industry has already agreed on a framework for approaching net zero by 2050. And whatever we can't solve with those other three, or all four of those columns, then there's an agreed to way to buy offsets or contribute offsets to make up the balance by that time. And I don't think a lot of other industries can really say that. But that's the name of the program that the globe has agreed that aviation will use to offset whatever remains of carbon emissions. So I want to now move to Cascade. So if you took that chart and you said, well, how do we make that come to life? And the challenge we started getting into was, how can we show people, let's start with regulators and policymakers. Let's show people what can make a difference. So I'm going to open up the tool in a moment, but before I do, let me orient you to it. That is the world's scheduled air transportation system. It's between the period of February of 2019 and February of 2020. We picked a particularly busy time. We didn't want to pick a time that was COVID depressed air travel. So that's the world's air system. And in that particular year, there were 32 million plus flights and almost 1 billion tons of carbon emissions. So we started saying, okay, what if we could show the effect of these other things? And oh, by the way, we could sort that data by aircraft type. We could sort it by airline. We could sort it by distances. We could sort it by the origins and destinations of the flights. So we wanted to be able to sort of carve that data up however we needed to look at it, depending on who we were talking to. And so then if you go to the next view, these are all the things I just talked you through: fleet renewal, future airplanes, ops efficiency, the new forms of energy, and carbon offsets if we need them. And so this is just a screenshot, one of almost an infinite number of scenarios you could put into the tool that say, well, what if, for that particular year in the life of aviation, what if I could have snapped my fingers and all the older airplanes were replaced by the current version of airplanes? So Airbus's latest airplane, Boeing's latest airplane, fleet renewal, 17% drop in carbon emissions, if we could just do that. And then when the pandemic hit, we were just starting an aircraft fleet replacement cycle. The MAX is only about 15% penetrated into its replacement market. Same with the Neo at Airbus. So we're entering another one of these cycles where more fuel-efficient airplanes are going to enter the market. There will be naturally some reduction in carbon emissions, but there's also growth that we have to try to overcome. We also looked at operational efficiency, big or small. We looked at sustainable aviation fuel. We said, what if you could snap your fingers and there was enough sustainable aviation fuel that every airplane that took off was taking off with a 50-50 blend of sustainable aviation fuel and regular jet fuel? You'd see a huge improvement in the carbon emissions of the industry. So you get the idea of the tool, and there's almost an infinite number of what ifs you could put into the tool. Importantly, we wanted to give it an ability to say, let's make sure we're modeling not just sustainable aviation fuel, but let's make sure we're modeling the cleanliness of the world's electric grid. Let's make sure we're monitoring the cleanliness of how hydrogen is produced. And then let's connect that to a future aircraft. So I'll show you when we open up the tool, what would happen if we inserted a hydrogen airplane in some particular year? Does it make the problem better? Does it make the problem worse? And what would change that and flip it over to having a positive contribution to emissions reduction? So Ellie, if we could jump into the tool, we'll run you around that in a minute. So here's the tool. You might want to shrink it if you can a little, Ellie. I don't know if you can. So here's the tool, same data I showed you, and 32 million flights, the 954 million gallons. Here's that data just looked at in a bar form. That's the same number, 100%. And then there's all the things we modeled. Are you able to shrink the screen view a little bit? I don't know if you can, but but if you put in future airplanes, and we'll just start to look at it the way I mentioned. If you go back to the top, Elia. Fleet renewal. Yeah, so fleet renewal, that's what we modeled, was current aircraft types and then future aircraft types. And the data I showed you a minute ago, we just dragged it all the way over to latest aircraft type and said, let's replace that. I think that's easy for you to see. Same with operational efficiencies. We can model that wherever you want between 0 or 10%. We gave it an ability to say, are we improving air traffic management? Are we modifying existing airplanes? Is it something in the ground or airport operations that's been changed to reduce the carbon emissions? So we can model the total improvement. But in renewable energy, if you open that one up and then scroll down, what we wanted to be able to, and open up SAF too, please, Elia, the yellow bar, open that one up on the right. Yeah, that's fine, but open up the, yeah, there you go. So we wanted to model two things. We wanted to model how much SAF is available, and if we took that to the 50-50 blend, if you move that over on top there, just move this one to the 50-50, Elliot, yeah. And then if we can model the amount of SAF that we have available, but also what pathway are we assuming for that SAF? Is it ethanol to jet? Is it HEFA? Is it Fischer-Tropsch? What's the feedstock? In essence, what is the carbon improvement of that fuel? And we wanted to be able to model different types of fuel and then look at what's the effect of that on the carbon emissions of the industry. But then if you scroll down, here's the electric grid. And here's hydrogen. And we modeled, you could pick, you know, when we go visit places in Europe, I think when you say electricity or hydrogen, it's almost assumed sometimes that it's green already. And then you start to, you can pick, where do you want to assume you are in the world? Whose grid do you want to model? We could model a completely fossil fueled grid. We can model a totally renewable grid. Same with hydrogen. If you go down, scroll down a little bit on hydrogen and open up the corner box, we can model the kind of hydrogen that we're making and the type of a process we're using to make it. Is it electrolysis? Is it steam methane reforming? How clean is the grid connected to it? And then you can connect that up to airplanes, future airplanes. So if we go back up to future aircraft, please, Elia. Sorry about the view being so big in here, but let's just say a hydrogen airplane. If you go into picking a hydrogen airplane, and then you make it a regional airplane, go into regional, make it 100% market share, take it all the way, give it like a range of about 800 nautical miles. We'll just design one real quick. Just, yeah, right there, that's fine. You can just put it wherever you want. Now you can sort of see that, and in the model, if we scroll back up, it should have, here you go, positive 4.7%. So when we saw that, we're like, huh, why is that? And I won't do it on the tool, but if we went back down now to the hydrogen production source and the grid, and we started pulling that to greener and greener, you would see a crossover point occur real time, and you'd see that plus 4.7 go to a negative number. And the only reason I show you that is because the life cycle carbon emissions of these different fuels, we're sort of very conditioned in the world to think about it when we think about jet fuel or fossil fuel. We're not as conditioned to think about it when we talk about electricity or hydrogen. But if they're going to apply to aviation's problem, we have to think about those things too. And that's what we were trying to bring to light with the model. So we can, I think you get an idea on the model, but you can see how it buys its way down towards net zero when you start playing these things. And we did this so that we could talk to policymakers initially and just say, if you're one of these people that's trying to write a policy around reducing the carbon emissions of aviation, try to write it in a place that will make the biggest difference the fastest. And that's, chances are, that's going to have something to do with sustainable aviation fuel as a no regrets move that you can make. And so we'll continue to operate this tool. Where we're headed with this tool is we'll eventually have 3 versions of the tool. It'll have one code base. It'll be hosted in a modern cloud. Right now it's behind our VPN, so it requires kind of a Boeing engagement. But we're eventually headed towards a public version of this. And we're in the process of forming a consortium around this. We call the tool Cascade. So we'll have a Cascade consortium, and we want to be collaborating with people that can both make sure that the models are credible that sit behind this, and that they evolve, and that as new and better models come to pass, we can connect them up. And just while I was here this week, we talked about the BioSteam model. You know, you already used the GREET model. That sits behind this data. We use GREET behind this data. The radar, the tracks in the picture you saw were from Flight Radar 24 and Sirius. So we use them to model the tracks. And right now, it's what I would call industry average data. We go to some airlines and they say, well, that's not my fuel burn. My fuel burn's better than that. And it's intended to not be anybody's proprietary data right now. It's intended to be industry average data. So I think you get the idea what the tool is. We can jump back out, Elia, and go back to the presentation. Thanks. So, I'd say on sustainable aviation fuel, I'd summarize it this way, which makes me hopeful that the industry is going to solve this problem, is in 2008 or 2005 or 2006, the question was, is this even possible? Can we fly an airplane on this stuff? And Virgin Atlantic flew a 747 on the first flight with sustainable aviation fuel in 2008. People say, can we fly military airplanes on it? We did it with the Navy and the Air Force on C-17 and Super Hornet. The fuel has to be qualified through an ASTM process as safe and equivalent to jet fuel. And then it gets considered to be a drop-in fuel. But there's been these big steps forward over time on sustainable aviation fuel. Now nobody's really asking if it's possible to do it anymore. People are saying, how do we scale it up? How do we solve the economic problem? How do we solve the feedstock problem? So your collaboration, Phil's collaboration in engineering with Andrew over at Cabby, super important. And it's a way to reach beyond sort of traditional aerospace engineering to how's it going to connect up to renewable energy development in the world. And sustainable aviation fuel is going to have this wide spectrum of innovation over the next few years on the types of fuels we're trying to make, the types of fuels we're trying to qualify to use in airplanes. So there's a lot of progress in that area, but a lot of progress to go and a big policy problem. So then, I mentioned that we kind of are all about SAF, and I'll show you two more pictures, and I want to take whatever questions you want. But electricity, I talked about this a little bit. I talked about WISC, so I won't belabor that. But a lot of people forget, when the 787 entered the market, that was a step forward change in electric power on an airplane. 787s carry around 1.5 megawatts of electric power. Now, they're not using it for primary propulsion. It's being used for systems on the airplane to take load off the engines, which can then be used for primary propulsion. And if you remember, we had a few troubles at Boeing during the development of that airplane. Some things caught on fire. We had thermal runaway. We had all kinds of things we had to learn about how you contain the batteries. We had some of the world's best minds in battery technology helping to solve that problem and how you contain thermal runaway and some of the make sure that's safe. But that was a big game changer. That was a big step forward in electric architectures for airplanes. WISC, if you had pulled out your cell phone, that airplane, 12 motors, flies on 3,000 of your cell phone batteries. They're all configured in a special way. There's certain battery packs. The operating empty weight of the airplane is about 70% batteries. So it's a big weight component of the airplane. And you all know that as the airplane flies, that weight doesn't decrease like liquid fuels. It stays as heavy as it was the minute it took off. So that affects your range and payload. So we'll learn a bunch of stuff from that. In the upper right is a program we do with General Electric and NASA. That's going to try to take 1 megawatt of power that on this airplane we distribute over 12 engines, and we're going to put it in a single engine on that airplane in the upper right. And if it works with one engine, we're going to put a second engine on the airplane. And so both engines will be megawatt class electric motors. And we'll learn some more about thermal management and all that. But there's a lot going on in electric aviation. But I do think the world is kind of coalesced around the fact that we're not going to fly very far on all battery electric airplanes. And we're not going to carry very much with all battery electric airplanes. So then I'll just finish with hydrogen. In the upper left is the first flight that ever occurred with a human with a hydrogen fuel cell powered airplane. And below that was liquid hydrogen. And this airplane right here autonomous airplane, flew with liquid hydrogen. And it's not very pretty, it's not very aerodynamically efficient. And that was all driven by fuel tank design, which in this case is pretty spherical because of the pressure that we had to maintain. The long lead item on that airplane was a fuel tank. So, and then I talked to you about the middle column. I talked to you about the far lower right, future flight concepts. That is an airplane that Phil and I talked about today. You know, if you thought that you could fly someday a 50 to 70 seat airplane, 1,000 nautical miles, zero emissions, that's an interesting airplane in the world that would start to change people's thoughts about route networks and things like that. So that's not a bad place to focus. I think Phil kind of highlighted that segment of the market as a place where, you know, if the technology ever let you do that, that starts to become pretty interesting in route networks and things. And then, you know, I love the people that say, ask the question, well, you know, do you think you can ever use hydrogen in aviation and aerospace? And my answer is usually we already do. It's called space and launch. And, you know, we launched a rocket with NASA in the 60s that put humans on the moon. We just launched the biggest rocket in the world with Artemis 1. And so we've learned a thing or two about flying with hydrogen. And we all know how complex it is to transport it, produce it, keep it where you want it to be, temperature control it, pressure control it, all those things that make liquid hydrogen or gaseous hydrogen so it's tough to pump around. But we know we can do it. We've done it before. We just have never applied it to scheduled air service. And, you know, you probably wouldn't want to be waiting at the gate until somebody figured out the hydrogen problem on your airplane just yet. But we got to study it, right? So my only point is our industry is going to do amazing work and prototype amazing things in electric aviation and hydrogen. And we're going to figure out what impact do those things have on the carbon emissions and footprint of the industry. And we're going to need the energy industry to come along with us with greener hydrogen and greener electricity. And that's going to take money from the banks that have to finance these new projects that are going to produce more of that stuff. And the policymakers have to help write the policies that are going to make that whole equation possible, especially in the beginning. So this program that you all are starting and that Phil is starting at Illinois around the Center for Sustainable Aerospace and its linkages to the companion components of the engineering school with the business school or the ag school or the finance industry, that is groundbreaking. And that's one of the reasons, you know, I wanted to come and see Phil early in this year is just to see kind of how'd that first class go. What did you learn? Do you think you're going to keep doing it? Did anybody like it? Did everybody hate it? But I think, you know, I really applaud U of I Engineering for trying something different and connecting it across the university because we like to say these are not problems we're going to solve together. We're going to have to solve it or separate. We really need the aerospace industry, the policy people, the finance people, and the energy people to come together to solve some of these problems. And the models that we need to think about these problems are one of the reasons we tried to create Cascade, and it'll only get better when we start collaborating with more people and better models get added to it. So that's what we came to talk to you about today. That's our view, and I'd be happy to stay as long as Phil will let me and answer any questions you want about Boeing, careers, aerospace, whatever you want to talk about. I'll answer any of it. I've had the privilege of being in a lot of jobs in the company. Phil hit on a few. Started in engineering, been in supply chain, been in program management, been in business development and sales, stood up our first autonomous business, ran an electronics and intelligence business, ran a missile defense business, ran corporate strategy, ran M&A, got asked to work a special project on the MAX, got asked to work a JV in Brazil with Embraer, and then got asked to do this job. So I've had the honor of having a lot of different roles in aerospace and kind of seeing how the dots connect. This might be one of the most challenging jobs, but I think that we're entering, you know, Phil called it the next big challenge of the industry. Or, you know, I could argue we're in the era of sustainable aerospace, and it's going to take a lot of amazing components to make that a net zero world. So thanks for being here today, and happy to take any questions you want.